Alrighty, so now that you have clearly mastered graphing the basic functions, we're going to make graphing harder. So what we're going to be doing here is we're going to be doing things like changing the period, we're going to be shifting the graph around, and we're going to change the amplitudes. So these are all secretly things you already know how to do if you know how to do transformations. And if you don't, these are a great chance to practice transformations. Our two goals, one is to graph transformations of trig functions, and then the other is to recognize sort of what transformation took place if you're just given a graph. We're going to be mainly focusing on the first goal, but we will talk a little bit about the second one. So, just briefly, in order to even start talking about graphing a transformation, first you have to know the graph of the basic function, right? You can't change something if you don't know what it is you're changing. And so, for example, and the example we'll be working with throughout the video, this is what we want to graph, y equals 2 sine of 1/2 x. And so the basic function hiding inside of there is just y equals sine of x. And so you can see down below here, right, this is just the graph of y equals sine of x. And on it I've labeled a bunch of points. Some of these are, all of these should be points that you know. And so here is just the very basic function of the graph of sine of x. You should know a whole lot of things about this. You should remember that the amplitude is 1, and that the period is 2 pi. Right? These are things that you should remember. And so we're going to see sort of what happens to this when we graph this y equals 2 sine of 1/2 x. So here I'm making the point that any transformation we do, right? So when we do something like y equals 2 sine of 1/2 x, that this feels no different than a normal transformation, this AF of bx plus c plus d nonsense that I know you guys love so much. And so just because we've moved into the land of trig doesn't mean that anything's changing. It's exactly the same way that we're doing it. And so look down here at two examples, right? So here is where all of the letters, the A, B, C, and D go, right, when you have something like sine or cosine. And so our main example right here, right, is y equals 2 sine of 1/2 x. If you line this up with a sine of bx plus c plus d, and you come over here to this box, you can see that a has to be 2, b has to be 1/2, and there's no c and no d, so they're both 0. Likewise, here in the example y equals 3 cosine of 2x minus pi, if you come over here to this box and you line it up under a cosine of bx plus c plus d, you can see that a has to be 3, right, because that's what's in front of cosine, and then b is 2, because that's what's in front of x. C is negative pi, because that's what's being added or subtracted to 2x there, and then d is 0, because there's nothing behind it. And so this is how you get your numbers, your a, your b, your c, and your d. Now, whenever we graph a transformation, right, what do? We take a point on the original graph and we transform it. And what that does is it moves that point somewhere else. And where it moves it to, right, is this. X gets moved by multiplying by 1 over b and then subtracting c over b. Y gets moved by multiplying by y and adding d. Those things, right, are down here in this table. The way you take any value, right, from your original graph and get a value on your new graph is you take the x and you multiply it by 1 over b and then add negative c over b. And then you take the y value and you multiply by a and then add d. And so over here on this side we have an example, right? Sine of pi over 6 is a half, right? And so pi over 6 comma 1/2 is on the graph of sine of x. And so look at this transformation, this 1/3 sine of 2x minus pi. Right, 1/3 sine of 2x minus pi. This is your a, that's your b, this is your c, right? And your d is 0. And so in this example, you just take the x value, which is pi over 6, you multiply it by 1 over b, which is 1/2, and then subtract negative pi over 2. And negative pi over 2, when you subtract it, will become positive pi over 2, and so when you combine pi over 12 with pi over 6, you get 7 pi over 12. And then you take the y value, right, which is 1/2, multiply it by 1/3, because that's the a value, and then add d, which is 0, and so that gives you the 6th. And so you know, because pi over 6 comma 1/2 is on sine of x, that this 7 pi over 12 comma 1/6 is on your 1/3 sine of 2x minus pi. Okay, so here's some facts. The neat thing about trig functions is that they're periodic, right? All of the trig functions repeat themselves every certain amount. Most of them are 2 pi. A couple of them, tangent and cotangent, repeat themselves every pi. But if you have a periodic function, and you have a transformation of the periodic function, and let me come in here, that's not a 6, it's unfortunate, that's a b, right? So this b here takes your period and divides into it and gives you the new period. And so, for example, sine of x has a period of 2 pi. So sine of 3x, you take that 3 and you divide it into 2 pi. So you get 2 pi over 3. So if you look here at this function, this is sine of 5 sine of 3x minus pi over 8 plus 3. Remember, the only thing that matters is what's in front of that x there. And so it also has this same period. And if you have 1/4 x, well, when you divide by 1/4, it's really like multiplying by 4, and so 2 pi over 1/4 is 8 pi. Likewise, this is also 1/4, and it's the only thing going on in front of the x, and that's all we care about when we change the period. And so this also has a period of 8 pi. Okay? So this just describes a way we can change how often it repeats. So the b always tells you if you're stretching or compressing horizontally. And so if you take the sine and you take your hands vertically and you squish it, that's going to change how often sine repeats. Alright, so suppose we have an amplitude. right? So for example, most of our amplitudes are 1, because we're only going to talk about amplitude in terms of sine and cosine, but if you have amplitude equal to 1, then the A out front, right, this A, is going to change your amplitude. And in particular, and you can see what I did here, I put this inside absolute values. And the reason I had to put it inside of absolute value signs is that the number out front could be negative, but the negative number doesn't really affect the amplitude any differently than a positive one. And so you keep it positive by taking the absolute value and you multiply whatever the amplitude is by the value out front. So, and you see my examples here, cosine has amplitude equal to 1, right? This has amplitude 1. 3 cosine has amplitude 3, right? But so does negative 3 times cosine of x, right? So if we're multiplying by 3 or multiplying by negative 3, that's multiplying the whole function by 3 or negative 3. That really has the same effect on the amplitude. It makes it 3 instead of 1, right? So it's going to make the function 3 times bigger. And so here, sine of x has amplitude 1, and so 3/4 sine of x has amplitude 3/4, right? And the same is true if we had negative 3/4. Remember, the amplitude is always a positive number. All right, so if we have a periodic function, and it starts at 0 f of 0, and just really quickly I'll draw a little picture. For example, sine starts there, and cosine starts here. Right? These are your 0 f of 0. This is your 0 g of 0. Right? These are the starting points for your functions, your periodic functions. So if you have a periodic function that starts somewhere, then we can shift it, right? And the amount it shifts is this negative c over b. And so what it's going to do is it's going to take your function, it's going to either slide it left or slide it to the right. And so here's 2 examples. Sine of 3x minus pi, you take the negative pi and divide it by 3, and whatever you get, you negate it. And so that winds up being pi over 3. And so instead of starting at 0, 0, it starts at pi over 3, 0, which means the whole thing is going to shift to the right by pi over 3. Likewise, y equals sine of 1/2 x, right, this guy here, sine normally starts at 0, 0, but this starts instead, you take the pi over 2, and you divide it by 1/2, and that's pi, and then you negate that, it's negative pi, and here's my negative pi. And so what that winds up doing is it winds up shifting pi units to the left, right? So it used to be 0, 0, and it winds up going to negative pi, 0, right? Just like 0, 0 wound up going to pi, 3, 0. And so this is a shift to the left instead of a shift to the right. And so now, here we go. We're going to put all of this information together and we're going to graph y equals 2 sine of 1/2 x. So remember, the first step is knowing how to graph the regular sine function. And so the way we normally graph the sine function, right, is we put together some information like I'm going to label pi and I'm going to label 2 pi here. And that makes this the halves. We'll put 1 up there and negative 1 there. Here are some of the normal points on sine, and they're connected via this gently flowing function. Here is y equals sine of x. And so the amplitude of 2 sine of 1/2 x is 2. Right? And so whatever my new graph is going to be is going to have an amplitude of 2. And so instead of going up to 1 and down to 1, it's going to go up to 2 and down to 2. Maybe that'll change because of a shift, but we'll see in a second that won't happen. Our period is 2 pi over 1/2. Right? And so let me go back up to the top and write a sine of bx plus c plus d. Right? B is 1/2, and so we take 2 pi and divide by 1/2, and that winds up being 4 pi. So our new period is 4 pi. And so that's going to affect how wide our graph is, right? And our starting point is at, well, it was at 0, 0. And so all we do, right, if we go back here, is we look at negative c over b, which is negative 0 over 1/2 times 0, comma, right? And now we go 1 times 0 plus 0. And that 1 came from our A, and the 0 came from the D. And so it's still at 0, comma 0. And so let's look at how we would graph that. So if this is 1, and that's 2, and this is 1, and that's 2, before our graph went like this, but now the amplitude is twice as big and the period is twice as long, right? So there's 2 pi, and instead the graph goes all the way now to 4 pi. And so here is a point on our graph. Here is the starting point, did not change. This is pi over 2, and instead of this value happening at pi over 2, it now happens at pi. And since the period is 2, it's going to go up to 2 instead. And then likewise, here at 3 pi, we're going to hit negative 2. And so our transformed graph is going to look like this. Y equals 2 sine of 1/2 x. And you can see here the period is 4 pi, and here the amplitude is 2. And so all we did was we took the graph and we stretched it and we made it taller. And so that's really what's going on here. Let's take a look at another example. So here we have that we want to graph y equals cosine of 2x plus pi plus 1. And you can see underneath I wrote a cosine of bx plus c plus d. And so what we're going to do is we're going to make our table. Right? And what we're going to do is we're going to multiply our x values by 1/2. And then we're going to add negative pi over 2. And to our y values, we're going to multiply by 1, and then we're going to add 1. And over on the right, you can see I compiled a small table of values here. And so let's go ahead and work on those. I'm going to multiply 0 by 1/2. Right, so working just up here on the first set, I'm going to multiply 0 by 1/2 and subtract pi over 2, and that gives me negative pi over 2. And then I'm going to multiply the y value over here, 1. I'm going to multiply 1 by 1 and then add 1, and that gives me 2. And so now let's work on these. I'm going to multiply pi over 3 by 1/2, right, which is pi over 6, and subtract pi over 2. And so that's negative 2 pi over 6, which is negative pi over 3. So this is negative pi over 3. And then I'm going to go ahead and multiply the y value, 1/2 by 1, and then add 1. And when you add 1 to 1/2, you get 3/2. And then I'm going to multiply, let's work on the next set of values. I'm going to multiply pi over 2, right, pi over 2 by 1/2. And then subtract pi over 2, and that's negative pi over 4. And then my new value is going to be, my new y value is multiply 0 by 1 and then add 1, so I get 1. And so, really briefly, here are my new values, right, which correspond to these old values. And so, really quickly, what I'm going to do is I'm going to take and I'm going to graph both the old values and the new values and show you how you can, just from some points, also figure out what the graph is going to look like. So I've started here with plotting the values that I have on my table for cosine of x. Cosine of 0 is 1, cosine of pi over 3 is 1/2, and cosine of pi over 2 is 0. Right? And, you know, cosine could keep going on. We could just keep graphing it, but we're not going to do that. We just want to graph 3 points to get an idea of where everything's going. And then if we look down at our table, right, we see that at negative pi over 2, so this this first point here, right, is moving, and where is it moving to? It's moving to negative pi over 2, comma 2. And so let's put a point there. And remember, that's where this point is going to. And so that's important. The next point is going to negative pi over 3, comma 3/2, which is there. And then the next point is going to negative pi over 4, comma 1. right? And if we connect those, much in the same way that we connected the other ones for our graph, we'll see that. And what you're seeing here is you're seeing this portion of the graph here being reflected right here. And so just like we could have kept drawing, we could actually keep drawing here. A little bit higher. This is going to be the graph of y equals cosine of 2x plus pi plus 1. And you can see what happened was the graph shifted to the left by pi over 2. Right? This shift here is negative pi over 2. On top of that, the entire graph happens in just pi instead of in 2 pi, right? And so the new period, remember the period is 2 pi over b, and so for us that was 2 pi over 2, which is pi. And so that's the change of period, and then the plus 1 here is what's shifting everything upward by 1, and so everything is above or on the x-axis. And so that's really the strategy here, is to use the normal transformation procedures to graph these transformations. They're not any different, so don't freak out. And more importantly, go over the homework, practice it, and then come see me in class. All right, bye.